You know, artificial intelligence is doing some absolutely incredible things, right? It's mastering games we thought were unmasterable. It's crunching these huge data sets. But here's the thing. There's this massive gap, a real chasm between how a machine thinks and how we as humans find meaning. And honestly, figuring out that chasm, it's one of the biggest challenges we're facing right now.
And this isn't a new idea. Way back in a 2001 paper, Dr. Yogesh Malhotra was already pointing this out, citing the great computer scientist John Holland. The point was simple, but so profound. We've gotten really good at the technical stuff, moving information around a network, but we've kind of forgotten to ask how meaning actually drives the whole thing.
So that brings us to this really fascinating puzzle. How can an AI beat a chess grandmaster, one of the most brilliant strategic minds on the planet? And yet that same kind of AI can completely fall apart in the business world, where the rules aren't just complex, they're changing all the time. What is going on there? Well, it turns out the answer is in understanding that there are really two totally different worlds of knowledge. And to get our heads around that, we're going to dive into some key insights from Dr. Yogesh Malhotra's foundational research, which just laid this problem out so brilliantly.
Okay, so on one side, you've got information processing. This is the machine's world. It's all about prediction, clear rules, logic, and driving super efficiently towards one single correct answer. But then on the other side, you have sense-making. That's our world, the human world, and it's all about anticipation, interpretation, intuition, adapting on the fly, and being comfortable with lots of different, sometimes even conflicting meanings. That is the chasm.
So let's take a closer look at the machine's world first. This is the home turf of information processing. For decades, this has been the dominant way we've thought about building expert systems in AI. At its heart, this model basically sees knowledge as a thing you can collect, neatly organize, and then hand out based on a fixed rulebook. You can almost think of it like a perfectly cataloged library. You know the system, you know the rules, and you can find any piece of information with perfect efficiency. It's an incredibly powerful idea, and this is a big but, it only works if the library itself never changes. And this is exactly why AI is a genius at chess. A chessboard is the perfect example of a stable environment. The rules are locked in, the pieces only move in certain ways, and the goal is always the same: checkmate. The information processing model is tailor-made to crush it in a world like that, to find the most efficient path to that one single correct outcome. Okay, so now let's hop over to the other side of that chasm. If the machine's world is a tidy chessboard, the human world is, let's be honest, it's a lot messier. But it's in that messiness that we find our greatest strength, the art of sense-making. Dr. Malhotra's paper uses this amazing term for our reality: wicked environments, and that's just perfect, isn't it? These are places where things are always changing, radically and without warning. The core assumptions you had yesterday could be totally useless tomorrow. In a wicked environment, it's like the chessboard itself is morphing and changing shape while you're in the middle of a game. So how on earth do you survive in a world like that? Well, the research points to these principles that are, honestly, they're the opposite of what you'd expect. You don't just rely on what worked in the past. In fact, you treat memory as a potential trap. You don't try to get everyone to agree. You actually encourage debate, what the paper calls creative abrasion. And you definitely don't look for the one right answer. You actively look for multiple, even contradictory, ways to see the problem. It's all about being adaptable, not just efficient. All right, so we've got these two very different worlds, right? The machine's logic on one side, human meaning on the other. So how do we possibly bridge that chasm? Well, Dr. Malhotra's work makes a powerful argument that the answer isn't buried in more computer science, it's actually found in human psychology. The key idea here is something called personal construct theory. And what it says, in a nutshell, is that we aren't just passive sponges soaking up information. Not at all. We are active builders. We're constantly creating our own unique mental models, our own constructs of how we think the world works. And why do we do this? For one main reason: to try and anticipate what's coming next. The psychologist George Kelly, who came up with this theory, put it perfectly. Our entire way of thinking, all of our mental processes, are organized around one thing: anticipating future events. See, we're not just predicting based on old data like a machine does. We're actively trying to make sense of right now so we can get ready for a future we know is uncertain. And this all happens in a constant loop. First, we run into something new, something confusing. Then we instantly form a little hypothesis, an anticipation of what it might mean. Next, we act. We do something to test that hypothesis out. And finally, based on what happens, we adapt. We tweak our mental model of the world. It's a messy, fast, and deeply human way of creating meaning as we go. And that gets us to the most important point of all. This isn't about which one is better. It's not human intuition versus machine logic. The real goal, as this research makes so clear, has to be synergy. We need to figure out how to use the incredible processing power of machines to support and to amplify our uniquely human talent for making sense of things. And this leads to one final powerful idea, cited in Dr. Malhotra's paper from the philosopher C.W. Churchman. And it is this. Knowledge isn't in the database. It's not in the code. Knowledge resides in the user. It's that magic that happens when a human mind takes information and creates meaning from it, anticipates the future, and decides what to do next. So that leaves us with a huge question for our own wicked environment. As AI gets more and more powerful, what are we building it for? Are we just designing it to be a more efficient information processor, or are we designing it to be a real partner in the most human job there is, the job of creating meaning in a world that is and always will be uncertain? You know, when we think about intelligence, whether it's ours or the artificial kind, we're really talking about two totally different ways of seeing the world. One way is to look back, to the past, to try and figure out what's happening now. But the other way, well, that's about looking forward, to create whatever is coming next. This is a huge distinction, and it's right at the heart of where intelligence is heading. So let's really dig into what it all means. And that brings us to a massive question for our time, especially with things like generative AI just exploding everywhere. Is this technology we're building actually looking forward? Is it capable of real innovation? Or is it just an incredibly powerful machine for replaying things that have already happened? This slide really lays it all out. On one side, you've got this backward-looking AI. Think of it like an engine that just replicates things. It's trained on these huge archives of data from the past. But then you've got us, forward-looking humans. Our intelligence isn't about replication at all. It's built on anticipation, our unique ability to create meaning and then project that meaning into the future. Okay, so to really get this difference, we have to talk about something called the meaning gap. It's this giant chasm that separates just processing raw information from actually making sense of it, from genuine human understanding.
And listen to this quote from the legendary AI pioneer John H. Holland. Way back in 1995, he was already pointing this out. He said the entire field was obsessed with this very narrow mathematical idea of information and was totally missing the most important piece of the puzzle, meaning. Seriously, that one word, it's the key to everything.
See, for a machine, information is basically a solved problem. It all goes back to Claude Shannon's theory, where information is just about reducing uncertainty. It's kind of like a game of 20 questions, right? Every answer just narrows down the possibilities. The information is all pre-coded, and any meaning it has was put there beforehand by a human. It's totally objective and static. But for us humans, it's a completely different game. Meaning isn't something you find. It's something you create. It's this deeply personal, deeply social thing we build. We take in new data and we connect it to this whole web of our own experiences, our beliefs, our emotions, and that's how we make sense of the world. It's subjective, it's dynamic, and it's incredibly diverse. This table just lays it out perfectly. Look at the difference. The basis, Shannon's theory for machines versus our own personal constructs. The goal, for a machine, it's just reducing uncertainty. For us, it's creating understanding. And the nature of it, objective and pre-coded for machines, but subjective and dynamic for humans. This is a fundamental fork in the road for intelligence. So what happens when this difference gets put to the ultimate test, right? What happens when the world gets messy and unpredictable and all the rules suddenly change? This is where that gap really becomes a chasm. We need to talk about what researchers call wicked environments. Now, these aren't just tough situations. We're talking about moments of radical, totally unpredictable change. Think about the 2008 financial crisis or the COVID pandemic, or when a new technology just comes out of nowhere and changes everything. In those moments, all the historical data in the world can become useless in an instant. And this is exactly where that backward-looking model just completely falls apart. And AI, because it's bound by its training data and its pre-programmed rules, is pretty much designed to fail in these environments. But humans? Well, we have an ace up our sleeve. It's called interpretive flexibility. We can use our imagination and intuition to just throw out the old rules and invent new ones as we go. Let's really look at the machine's fatal flaw here. It's designed to follow the rules,
to enforce compliance, and to minimize any deviation from past patterns. Its whole operating system is built on one core assumption, that the future is going to look like the past. As the source paper puts it, its repertoire of response remains impervious to experience, especially when that experience breaks from everything it was trained on.
Now compare that to the human advantage. We use imagination, insight, intuition. We're not afraid of making mistakes. In fact, we're constantly on the lookout for errors so we can correct them. And crucially, we can hold multiple, even contradictory interpretations of the exact same data in our heads at the same time. We are, as the psychologist Jerome Bruner famously said, capable of going beyond the information given.
So how does it actually work? This human engine of adaptation, I mean. What is the mechanism behind our ability to anticipate the future instead of just, replaying the past?
Well, the answer seems to lie in this really powerful idea from a psychologist named George Kelly. It's called personal construct theory. And what it says is that every single one of us is basically acting like a scientist all the time. We're constantly creating these mental models, he called them constructs, which are really just our personal hypotheses about how the world works. And we do it all to try and anticipate what's going to happen next. And this isn't some passive thing. It's a super active cycle. First, we anticipate what's going to happen. That's our hypothesis. Then, we act, we go out and do something to test it. Next, we experience the result of that action. And finally, we adapt. We revise our mental model based on whether we were right or wrong. This is what real learning looks like, not just matching patterns.
And what's so critical to understand is that this is not some cold, logical process like a computer running code. As the source material really emphasizes, human sense-making is an integrated whole. It's a synthesis of our feelings, our thoughts, and our actions. You can't just pull cognition out from emotion. They work together to create meaning.
This quote just captures the results so beautifully. Because our personal constructs are unique, we all live in our own unique worlds. I mean, two people can see the exact same thing happen and have completely different experiences because they're interpreting it through completely different mental models. And this incredible diversity of interpretation, that's the engine of our collective creativity and our resilience. It's a world away from AI's push for a single optimized answer. All right, let's bring all of this back home. We've talked about replication versus creation, about information processing versus true sense-making, and it seems pretty clear that the future of intelligence, well, you're not going to find it by just looking in the rearview mirror. Here it is, maybe the sharpest way to put it. Machine learning is designed to predict the future, but it has to assume the rules of the game are going to stay the same. Human sense-making, on the other hand, is designed to anticipate surprise and to actually redefine the rules of the game while it's still being played. So where does today's generative AI fit into all this? Well, it's the ultimate rearview mirror. It's an absolutely mind-blowing tool for remixing, rehashing, and replicating the entire digitized history of our collective past. It can show you what has been with stunning accuracy. But here's the thing. A mirror can't show you where you're going. Human imagination, that capacity we have for forward-looking sense-making, that's the compass. That's the engine for creating new, novel, totally unforeseen futures. And this very idea of a forward-looking, meaning-driven intelligence is what's inspiring the next frontier of AI, systems sometimes called forward AI or quantum minds, designed to work with human creativity, not just copy it. And that really leaves us with one final big thought. As we face down all the complex, wicked challenges of our time, from climate change to social upheaval, we have to ask ourselves a pretty simple question. What do we need more of? Do we need even better mirrors to give us a perfect reflection of our past? Or do we desperately need better compasses to help us chart a course to a future that has never existed before?